So today we're going to start talking about services, and we'll explain various kinds of Android services, and we'll discuss these things in the context of an application that's very much like what you're doing for the next programming assignment. So we'll go ahead and dive into that. Okay, so just to give a little introduction to what we'll be covering. Services don't have a user interface. They rely on other things to get the user interface interactions, and they're most commonly used to run certain operations in the background, especially long-running operations that run in the background. Typically, activities are the things that are going to be used to invoke operations or send requests, intents to services to do the work on the behalf of the activity. There's other ways, of course, services can communicate as well, but that's one of the more common ways to do things. And there's a number of very interesting inter-process communication, or so-called IPC mechanisms, that are used in order to be able to allow activities and services to talk to each other, or different services to talk to each other, and so on and so forth. And so we're going to be talking about a lot of those topics throughout the rest of this particular module. You'll see that you could talk about some of those things in isolation from services, but they're so closely aligned that it really makes sense to talk about them together. So we're going to spend some time talking about services, and as we talk about different kinds of services, you'll understand why we have a variety of different kinds of inter-process communication mechanisms to interact between the different kinds of services. Okay, so the first part of this module is going to kind of give you an overview of what a service is, not unlike the discussions that we had when we were talking about the activities. So this is kind of the same parallel structure that we were using back then. So a service is an Android component. It's a component just like we have activities or content providers or broadcast receivers. It's one of the 4 core components that are part of the Android application programming infrastructure, or application architecture, I suppose is a better term. And they're used to run, typically to run long-running operations in the background. You'll see there's a whole variety of different ways to interact with services, but a very common approach is to run them in the background. And you can do all kinds of interesting things in services. You could handle some kind of network interaction. You could send requests, receive requests. You could download a file, kind of what we're going to be doing here, like an image. You can interact with some kind of content provider on behalf of something else in the background. You could run periodic tasks that have to run on the passage of time or when certain data shows up. And you'll see there's lots and lots of examples of these things. In our particular environment that we're going to talk about for the next assignment, and what we'll cover here today and the next few weeks, is a download service, something that downloads files on your behalf. Now, there is an existing download service that's part of Android, and so you could certainly use that, but we're going to get some experience actually building a service so you can get a feeling for how it works. There's a lot more information that's available on the Android website, and I strongly encourage you to take a look. Really well written. It gives you a good feeling for how it works, shows you a whole bunch of examples and so on. So it'll help get you up to speed if you have any questions about some of the details. Typically, other Android components are used to start services. Most commonly, activities are used. And one of the things that's interesting about a service is it can continue to execute in the background even if the activity that initially launched it happens to go away, or if the user switches around to a different activity. That service is still there on behalf of the original activity, doing stuff on its behalf. And of course, there can also be system services as well, things that are long-running, not necessarily pegged to any particular user activity at all. There's system services that do things like location service, keep track of where the phone is, and the radio, managing communication, messaging, things like SMS and MMS and so on. Those are services that exist, that kind of are there to be run when things happen in the system. Since the service doesn't provide a direct interaction with the user, that means that you can't make calls to widgets in the context of a service. You already probably knew this a little bit from our discussions we had before about things that run in the background, things that run in threads, for example, that are not the main thread. But a service may or may not run in the main thread, but regardless, you're not supposed to make calls in the service that interact with the user interface. Under some interesting circumstances, you might be able to get away with it, but you definitely don't want to write code that depends on this, because it's very easy to change the context in which a service runs simply by modifying some of the metadata, some of the Android manifest file properties. And we'll look at some of those things as we get a little bit further along. Now, the main thing we're going to talk about today, and then we'll go into a little detail on one of these things, is the two different types of services. So in Android, there's something called a started service, and there's something that's called a bound service. A started service is the simpler of the two in some sense. It's simpler to program quickly, although it may not be simpler to use because it has some restrictions and limitations that are not there with a bound service. So a started service is typically used to perform a single operation, and oftentimes it doesn't necessarily return a result directly to the user. It might. You can program it using various IPC mechanisms like messages and so on to return results, but it's not necessarily always the case. So we'll see there's a whole pile of examples of started services we'll look at in a second. A bound service, in contrast, is typically something that's started when a client starts it up, and as long as the client or clients are talking to it, then it provides a way of making client-server calls, invocations on that service. And as long as someone's bound to the service remains running, and so you can actually carry out some kind of long-duration conversation with the service that's launched. And we'll see there's a bunch of those kinds of services as well. When we get a little further along, you'll see that there's a bunch of interesting patterns that are implemented by these various services. And the started service implements something called the command processor pattern, and the bound service implements something called the broker pattern. And we'll look at both of those patterns throughout the next few weeks. So how do you start a started service? Very simple. You call start service. And typically this is done by an activity. And usually what happens is you create some kind of intent, and you either give a specific service that you want to invoke, like the threaded download service .class file, which is kind of hard-coded to one particular thing. Or you can rely on some intent filtering mechanisms that are part of the Android intents framework. We'll talk about that a little bit later. However you do it, though, you create this intent, and then you go ahead and potentially add some additional things to the intent. They're called extras. You can put in various things like a username, URL, password, various things that you might want to use to communicate from the caller, the activity, to the service. And then you go ahead and say start service. And the Android system uses the intent together with the information in the intent, the action that the intent corresponds to, the data that may be in there, the category of the intent. All these things are factored in to allow the Android infrastructure, the so-called intents framework, to figure out who's going to handle this intent. And if that service isn't running, then Android will start the service, and it will deliver the intent to that service. And if you take a look, there's a link here that goes to the part of the service web page that explains how you create a started service. And it just kind of walks through these points. We'll talk shortly about the lifecycle hook methods that are invoked here when we get a little bit further along, and we'll talk a bit more about this. When you call start service on when you call start service and pass in an intent, then once Android figures out which service is going to need to run, it launches that service, or if it's already running, it finds out where it is, and then it goes ahead and it delivers the intent to the service. And it does it by calling back a predefined hook method that you're often obliged to override, not always, but typically is the case, called onStartCommand. And so what happens here, of course, is that the onCreate command of the service is called to kind of initialize it, and then onStartCommand is called, and that passes in the intent along with some other stuff that may have been passed with the service. That's passed in, and that's how you get a chance to find out what the client that started this thing wants to have happen at this particular point. So then at that point, you can do whatever you need to do to process stuff. In our particular example, then, and I'm skipping over a bunch of things here, and I'm not showing you all the details because we're going to cover it later. You might have a service that's going to download files, and so in that service, we're going to have some method called download file or download bitmap or download something or other, and it's going to take whatever's passed in, which it might very well get from the extra that was passed in, and it'll then turn around and download the file. Now again, there's a whole bunch of different variations on a theme here, but let's assume for sake of argument that our service is running in a background thread or a background process. Then that thing can block without affecting the way in which the activity is going to behave, because the activity is actually not doing the blocking. Okay, any questions about any of that? Something I'll talk about later. There's no necessary reason that a service that's started, either a bound service or a started service, will run in a separate thread of control than the caller. But it's not uncommon to have that happen. In fact, it's also not uncommon to have the service run in a separate process. And we'll talk more about running things in processes and threads and what the trade-offs are between these as we get a little further along. When the operation is done, then the service can be stopped. And it can do this a couple different ways. It can call stop self. It can stop itself. Or it can have some other client stop it. It can have another client say stop service, which will shut it down. So for the one-shot service kinds of things, they typically stop themselves when they're done. And that causes the service to be destroyed and the resources are reclaimed. OK, so that's basically started service. There's a bunch of examples of started services. We'll talk more later about how you determine whether something's a started service or not. The long and the short of it is that it's typically called by start service. And it has a hook method called onBind, which we don't show here because it's not relevant for started services. And that typically returns null. So that's a good indication that something is a started service versus a bound service. We'll talk about the bound service later. So with the started service, then some examples would be the MMS and SMS services that are used to process MMS and SMS messages that go to and from the device. When a user makes an SMS request, it can start a service to do the actual transmission of that device because it's going to go out over the network over top of TCP/IP, for example. Likewise, when data arrives on the network, then that also goes to a service called the transaction service, which is a service that runs in the SMS MMS implementation, and that gets the message from the network stack and then figures out how to get it to the user, typically by using some kind of notification prompt to alert the user they have an SMS message and ringing a bell or beeping or something like that. Another example of a started service is something that's called the alert service. This is defined in Android to handle calendar alerts, like it's, you've got a meeting in 15 minutes, and so a little alert pops up and says, you have a meeting in 15 minutes, don't forget to show up, or class starts or whatever. So those are good examples of started services. They're kind of one-shot things. They run, and when they're done, they go away. And they get reconstituted every time there's more stuff to do. So the key theme with the started service is things are activated on demand. And keep that in mind, because we'll talk more about that as we get a little further into the patterns that underlie this stuff. A couple other things to note. So if you are interested in learning more about services, go over and take a look at Android, at the implementation of Android. And let's see, I'll go show this to you. So hopefully my network is working. There we go. So we'll go look at Android 4.1, packages apps. So in packages apps and in a couple other places like packages provider and so on, there's a bunch of services that are defined in here. And if you do a find operation or you search, you can find lots of examples of different parts of Android that have services. And you can see there's a whole pile of them in there. And so I recommend, if you're curious to see how you implement a service and you're not really sure how, go take a look and see what you might find in there. You can see that there's also some that are part of the providers directory, like the download service, for example, and media scanner service, the MTP service, which I think is used for transmitting like image, camera pictures and stuff like that, and so on and so forth. Okay, so that's just some places to go to look to find examples of services, industrial strength examples of services, things that come from Android itself. Okay, so that's a started service. Let's now talk about bound services. We're going to come back and talk more about each of these things, and I'll show you examples of how to program them, and we'll talk about the patterns that underlie them, and so on and so forth. That's just a quick tour overview. So a bound service can be used by an application component to start the service if it's not already running, and if it is running, to bind to it so it can carry out a conversation over a connection that remains up and running for some period of time. So where a started service is created afresh each time you invoke start service and it's not already running, the bound service is typically started, and as long as there's someone connected to it, it'll stick around. It's persistent, it's sticky. And as a consequence, it's more efficient if you're planning to do a long-running set of interactions. If you're just planning on sending an SMS message and then not doing something for a long time, started service makes more sense because it's not going to keep Android resources tied up while you're not using it. So the way that you actually use a bound service is not unlike the started service in some respects. You create yourself an intent, and you go ahead and figure out who it is you want to talk to, what the name is of the particular element that you want to be able to interact with, what's the name of the service you want to talk to. But rather than calling start service, you instead call bind service. And as you can see, bind service takes the intent, but it also takes some other stuff. It takes something called a connection. And we're going to talk about this a little bit later when we look into more detail about how bound services are actually programmed. But for the time being, what happens under the hood, when you read the documentation, it's a little bit confusing at first. There's kind of this dispatching that takes place back and forth. There's sort of a handshake that takes place between the client and the server. And state is typically set up on both sides in order to be able to optimize later communication. And we'll look at all that stuff in much more gory detail when the time is right. You can take a look at this link to learn more information about a bound service and how to program it, what it does. When you call bind service, that results to a couple of calls on the service side, the implementation side. So of course the onCreate method is called to initialize the service. And then there's also a call that's made to something called onBind. And onBind is a factory method that is typically used, if you're implementing a bound service, to return a so-called binder or iBinder reference. And this is something that typically points to an object that lives in the service context. And what it gives back to the caller is a proxy that is used when the caller of this service wants to send data back and forth. And you'll see part of the dispatching and the handshaking that takes place is to exchange the proxy from the services side back to the client side so the client can stash it away, and then it can make direct method calls on this particular proxy in order to do its thing. When we talk about bound services later, we'll talk in detail about the proxy pattern, which is used to basically provide an interface the client uses to access the implementation of the service, irrespective of where that thing resides. Is it in the same address space? Is it in a different address space? That's up to the configuration mechanism that's used. You can decide this using your manifest file. And it's also something that Android can optimize in a few cases. If it can discover something as local, it can go ahead and short-circuit some of the inter-process communication. So we'll come back and talk about that a little bit later. That's not going to be the focus of today's class, but we'll talk about that on Monday. So, as I mentioned, there's this really interesting dispatching handshake protocol that's used to go back and forth. This is one of those things where it really pays to have an interaction diagram to show the back and forth callbacks, because otherwise it's somewhat mystifying who gets called and when they get called and what context they're in and stuff like that. So we'll look at that when we get to the right point. Once you've got a bound service, then you can go ahead and invoke operations. Now, the typical thing to do, although by no means the right thing to do or the most appropriate thing to do, is to do two-way synchronous invocations between the client that has the proxy it got back from the service implementation. So the client can invoke an operation, like it might say download image. And then, on the other hand, you've got the service and the object that implements this thing running perhaps in a different context, maybe even in a different process. And so those are the two parties that are interacting here, communicating back and forth by method calls. And out of the box, unless you do something to the contrary, you get so-called two-way synchronous communication. And what that means is that the caller blocks waiting for the call to return. And that call may take place someplace else. The way that the communication actually works under the hood, and we'll look at this in quite a bit of detail later, is by using something called the binder. And the binder framework is a local loopback-based intra-device communication framework that's used to ship typed messages from point A to point B, where point A and point B may reside in different processes. They don't have to, but they may. And it's responsible for doing a bunch of magic to handle all the communication details, the memory management, the connection management, the data transfer, and so on and so forth, necessary to move data from one address space to another address space. And we'll talk more about that. There's a lot of cool stuff that lurks in the context of these proxies and how they work. And the way that you program this stuff is by something called the Android Interface Definition Language, or AIDL. And if you're familiar with Java and Java interfaces, AIDL looks almost identical to Java interfaces. There are a few differences, but it's very, very similar. And it's actually processed by a pre-compiler, by a translator that takes the descriptions of the interfaces that are defined in AIDL, and it automatically generates these things called proxies and stubs. And we'll come back and talk about that. Now, I mentioned, and I'll just say this in passing now, we'll cover it much more detail later. Out of the box, unless you do something to the contrary, these communication calls are two-way, request, response. You block, you wait for the response to come back. It is not hard at all, by using some interesting patterns that we'll talk about, in order to be able to change from two-way synchronous communication to be able to have asynchronous communication between the caller and the service. And the trick is to define essentially one-way operations in AIDL, and they don't block. And so you'll end up with two one-way operations, one to pass a request to the service, along with a callback. And then the service, when it's done processing, takes the callback and then invokes a method to get the response back to the client. So we'll talk a lot about that. That's actually my preferred way of using this stuff, although you'll have to dig a little bit to find a lot of discussion about this in the Android literature. A lot of people don't really think about this too much, and as a result, you can write software that tends to behave improperly if things take longer to run than you want. Can anybody think about why you might have some problems if your calls block synchronously between the activity that invokes them and the service that processes them? What's the whole problem we have in Android about not having long-running operations in the activity? It'll block the main thread of control. It'll wait too long, and you'll get the application not responding, the dreaded application not responding, or ANR exception thrown, and then you'll have a bunch of problems on your hands. So for that reason, it's often a good idea, if you really want to build bulletproof applications, to do them as two one-way calls as opposed to one two-way call. Even though it takes a little bit more work to do it, makes your program a lot more robust and resilient. And so we'll talk about some of the patterns that can be used in Android to do that. In fact, in some sense, it's a little bit like the active object pattern we were talking about before, where you have the callback model with active object. If you recall active object pattern, there's a couple different ways you can use it. You can invoke an operation, then you can sit there and you can poll, trying to get the result, or you can invoke an operation and give it a callback, and when the thing's done, it'll call you back. And that's kind of the way that the asynchronous model works for dealing with AIDL and brokers and stuff like that. So we'll come back and talk about that. Under the hood, this is all implemented by something called the binder driver, which is a device driver that lives in the Linux kernel, and it handles all the low-level communication. And if you really want to trip yourself out, take a look. The code is written in C and C++. It's very low level. And there's actually a few people around here who've looked in detail at that code. So Jules White is kind of an expert on binder driver implementations. So if you're ever curious about that, you could ask him how it works. Now, unlike the started services, where it's kind of a fire and forget model, you start them up, and then when they're done, they shut themselves down when they're finished with that one request that they're processing. With bound services, typically the bound service will run for as long as there's a client that's bound to it. And as long as that client's there with a binding, then that service will continue to run. So that's really meant for long-running conversation type interactions. And of course, when you're done, if you want to get rid of the service, you can call unbind service. And if you're the last client who unbound a service, then it'll go away. And it'll destroy itself. Typical life cycle kinds of operations done through callback hooks, not unlike activities, very much the same kind of idea. Okay, any questions about this concept? Yeah, John.
Are there permissions related to the services? Because I know it's really easy to bind yourself to it, but then when you're, like, for example, stop service, you don't want anybody to necessarily stop all services.
Yeah, so you can also control those kinds of things. And Android has pretty sophisticated permission checking system built into its Activity Manager service that makes sure that you're given authority to talk to various parts of the system. Absolutely, yeah. Here's some examples of bound services in Android. So we have the Bluetooth headset service, which is kind of a funny thing, but that's used as a bound service. Media playback service, which is used to basically play media, files, audio, and stuff like that, video in the background, which is important because you don't want, if you're switching activities, but you want to play a song, but you want to switch activities, you don't want the music to die the second you switch activities. And there's also some interesting stuff with the way that Exchange email works in Android. It kind of runs a service in the background and is used to transmit diffs between, or to synchronize, do data synchronization between what's on your phone and what's on your cloud server running Exchange. Undoubtedly, there's also similar kinds of things for Gmail, but the source code is not easily understandable. Gmail, as you probably know, does not come with source code. And even if you are so brazen as to reverse engineer the bytecode back into Java, you will find that the people who wrote Gmail have obscured the code. So they have a little tool that runs through the software before they ship it, and it changes all the method names to, like, 1, 2, 3, 4, and it changes all the variable names to like A, B, C, D. So if you read the code, it is absolutely incomprehensible what it's trying to do, with a very few exceptions. So that's because they consider that very important. I think they do the same thing with the maps code as well. You can't really see what it does by decompiling it. Okay, so to kind of wrap up this discussion, applications can use services to implement long-running operations that take place in the background. Started services, as we'll see in the next part of this module, are very easy to program from the point of view of just starting them up and passing them some intents. And then bound services are a little bit more complicated to program, but they also give you some other powerful communication mechanisms. They're a little bit more like normal programming, invoking operations on objects, but where those objects reside can be left to a late binding decision. Okay, any questions about the overview? So for your next assignment, you'll be doing a variety of things, but one of them is you'll be doing the started services. In fact, you'll be doing something called an intent service. Okay, so now what we're going to talk about is how you would actually implement services, and the way you're going to subclass them, and some of the lifecycle hook methods and so on. And we're going to start by talking about started services. And then I think probably Monday we'll continue on talking about bound services. And as we go through the discussion, we're going to try to emphasize both the commonality and variability that's provided by the different mechanisms in Android. It's a framework, after all, so it's got this neat property of commonality and variability. And once you understand those properties, it makes it a lot easier to figure out what it's doing, and it makes it a lot easier to figure out how to extend it and customize it for your particular needs. So in many ways, implementing a service is a lot like implementing an activity. You inherit from some base class, service or intent service or something, and you override certain hook methods that handle lifecycle activities for creating the service or getting intents passed to it or shutting it down and so on. And then you have to go ahead and include the service in your manifest file so it knows, so that the system knows of its existence and can automatically start it up when necessary. You typically, Android typically informs a service that things are happening by invoking callback hook methods on it at the appropriate time. And so from a commonality and variability point of view, a service gives you a common way of being able to describe activities that run in the services that run in the background, functionality that runs in the background, or capabilities that run in the background. And that's the common part. It gives you a common interface with common hook methods. And then it provides you with this set of hooks that you can override to fill in the blanks for your particular kinds of service. So let's talk about some of these hook methods. You'll see that there's slightly different hook methods for started service than there are for bound service. They both have onCreate methods, no surprise. That's kind of the virtual constructor that's used to initialize a service when it's started, however it's started. The onStart command is called each time a service is sent a command via start service. So that'll be called back, and that's what's going to give you the intent that was passed. This is what a started service does. Keep in mind the bound services don't work quite the same way. And then after you've been stopped, after your service has been stopped, either because you stopped it or someone else stopped it, then the onDestroy hook method gets called to let itself clean up. So that's kind of like a virtual destructor. That's what's used to clean up the resources. Now here's something important, and this is a little bit confusing at first. There's nothing in a service that causes it to automatically run in a thread, a separate thread or a separate process. If you don't do anything to the contrary, you just make a service and you have an activity start it, it will actually run in the same thread of control as the activity that called it. It just will have some restrictions on what it ought to be able to do, like it can't access user interface mechanisms. There's a whole pile of easy ways of getting it to run in other contexts, however, and we'll talk about a few of them. You can spawn a thread and have it run under control of a thread you spawn. It's kind of called a free threading model. There's also some other mechanisms we'll talk about later about how to get it to run in separate processes or threads. OK, so let's talk a little bit about how we program this. This goes into more detail about what we had talked about before. So you start this thing by calling start service, typically an activity. And keep in mind, by the way, that things like start service and bind service, these are all inherited through something called the context. And the context kind of provides this implicit context that's always available in an application that you write. And not surprisingly, it has a bunch of thread-specific data, and it stores things in a per-thread manner and so on. So what you typically do is you typically create an intent. An intent is basically a data structure that keeps track of some state and some flags in a canonicalized way. And it basically is used to identify who is going to process this thing. And you can either have explicit ways of saying, I want this intent handled by this particular service implementation. That's explicit mapping of intents to services or whatever. Or you can let the intents framework ferret it out on your behalf by taking a look at what's in your intent and then seeing what types of services, activities, broadcast receivers, et cetera, what kinds of components have registered through using something called intent filters to receive the information when it occurs. You can also, like I mentioned before, put extras into the intent, so it kind of puts these things into a message. And when you're done, you go ahead and call start service. The start service call doesn't block, so it's going to do the minimal set of things necessary to get that request sent out across to whoever the receiver is, and it'll return right away. The intent will then be delivered by this call to start service, which is defined on the service itself. The other thing to remember is that these started services typically just do one thing. So here's an example of where we do onStart command and something happens. Started services do not return results to the caller directly. They do return a result. So onStart command returns a result, but it's actually returned to the server side or the service side Android framework, and it gives some information about how to treat this service if things crash or get stopped and restarted. So you can say things like, redeliver the intent. If the service gets shut down and then comes back up again, then if you return a certain value, the intent will be redelivered. You can also say, don't redeliver the intent to the start command. You can say, don't restart this service unless the application restarts it. So there's a bunch of different ways to indicate to the Android framework how it should treat this service with respect to its life cycle if it gets shut down unexpectedly. And remember, in Android, you can be shut down unexpectedly for all kinds of reasons. Usually it's the case, especially back in the bad old days when there weren't a lot of resources, you'd be running low on memory, and the low memory killer would come along and say, that service is running in the background, there's no user-directed activity to it, let's go ahead and kill it, and let's shut it down. And so this is used to control what happens when there's memory again and it gets started back up or not. And you can take a look, there's some discussions about how some of the semantics have changed a little bit with service behavior over time. Once you've implemented the service, and we'll look in more detail about how to do this in a second, then you have to register it with the intents framework, with the Android infrastructure, with the activity manager, which handles services as well as activities. I don't know why it's called activity manager. It should be called the intents framework service or something like that. And basically what you have to do is you have to tell it about the services that you're making, and it goes in your manifest file. So here's an example of some of the snippets of some of the stuff that you'll find in Android. So for example, for the MMS service, you've got this thing called the transaction service, which is a service that's used to send data. When you send an MMS, the service is used to actually deliver it over the network, over the cellular network to some cellular MMSC, I think, MMS service center or something like that. It's used to direct the data. And that could block, so it runs in a separate context. And then there's also an SMS receiver service, which is used when SMS messages come into the system. That gets called back to deliver the messages to the right place. And you have to indicate this in the manifest file using tags, similar to the kinds of tags you would use for delivering things to activities or describing activities. One of the other cool things you can do is, with just a little tiny tweak to your manifest file, you can actually direct Android to run your service in a separate process. So what does that mean? Well, normally your service runs in the same process as the caller. By starting something in a separate process, there's a bunch of interesting things that happen. Does anybody want to hazard a guess as to why you might want to run things in a separate process?
If the process hosting your activity gets killed, you may not necessarily die.
So if your process gets killed, and it might get killed, or it may crash, or it may hang, or all kinds of bad things can happen. This is a little bit less important in Java than it is in C and C++, because it's a little harder for services to go berserk in Java and crash other things than it is in C and C++. I mean, if you really work at it, you can cause trouble in Java, but it's a lot harder. And so running things in processes for isolation is a little bit less important. But it does give you this isolation property. And you can also sort of share things and have them in common. And there's a whole bunch of other stuff you can do. So I recommend you take a look and read up on starting services with the process directive. What I'd like to do now is give you a little bit of an overview of the intent service. And one reason to give you this overview is because this is one of the things you're going to have to program in the next programming assignment. So what the intent service is it's basically a very common way to program a service. And it defines a base class that inherits from service. And then you'll come along and subclass from that base class. And so typically what happens is when you launch an activity that is, or when an activity launches a service by start service and it's an intent service, then some magic happens behind the scenes. And we're going to talk about that magic. You can take a look at this link to find out more than you ever wanted to know about what intent services are intended to do. So basically what an intent service does is it handles requests that are intents, and it runs them asynchronously in a separate thread of control relative to the caller. So the intent service runs in a separate thread, and it does some interesting stuff. And the way this works, and it's actually really interesting to look at the implementation of intent service. We can kind of poke around with that if you're curious. But basically what it does is it automatically starts up a separate thread when the service is started. And as long as there's work for the intent service to do, then there's a worker queue. We'll talk more about this in a second. And it repeatedly pulls the data off the queue, and it goes ahead and calls the onHandleIntent hook method. And that's where you write your code. So you subclass this thing, and you write the behavior of what onHandleIntent does. And you can be assured that when that thing is running, it is running in a different thread of control than whoever called it. So we'll talk more about that and the pattern that embodies. The pattern, actually patterns that this particular mechanism embodies are the command processor pattern, number 1, which is a POSA 1 pattern, Pattern-Oriented Software Architecture Volume 1 pattern. And it also embodies the activator pattern, which is a pattern that should have appeared in POSA 2. It appeared in a couple other places. You can get it from my website. We're in the process of about starting the second edition of the POSA 2 book, and I assure you that Activator will go into the second edition of POSA 2. So it'll be in there where it belongs. And it's basically a pattern for launching services or contexts or processing on demand. So those are the two patterns that are implemented by the intent service framework. So when the client calls start service with the intent, then that goes ahead and causes the intent service to be created. And in the onCreate method of the intent service, it goes ahead and does some stuff to get a thread up and running. Let's take a quick look at that. It's kind of fun. Go take a look and see the implementation if I can find it. Let's see, find extends service. There we go. So this is the intent service, and as you can see, an intent service is a service, so it inherits from intent. Let me get rid of the funky coloring here. So an intent service is a service, and it's an abstract service, which means you have to come along and fill in something. And the something that you have to fill in is this abstract method called onHandleIntent. So that's what you're obligated to fill in. Now, it's got this really interesting pattern that gets used all over the place in Android whenever people want to write started services that run in the background in a separate thread. And basically the way it works is they define something here called a service handler. And if you Google, if you grep or find or whatever an Android source code for service handler extends handler, you'll see this example shows up many different times. So what it basically does, and this is kind of funky, it defines a class that's nested inside of intent service, and this guy essentially is going to be passed a looper, and we'll see the looper is going to be connected to a separately spawned handler thread. And then there's a handle message method. Remember, a handle message is what gets called back when you do a send message to something. This handle message method is going to turn around and call handleIntent, onHandleIntent, which is actually inherited by the subclass of intent service. It'll call this guy back in order to deliver the message in this other thread of control. And then it'll go ahead and stop itself. So it'll go ahead and shut itself down once it's done. All right, so that's kind of how the service handler idiom works, and you see this all over the place. Here is the onCreate method. So what onCreate does, as you can see, it goes ahead and it creates a new handler thread. Remember, a handler thread will be running in the background. It creates a thread that'll run in the background, and it starts it. So this thread is now running, and then it goes ahead and it grabs that thread's looper, and it stuffs it into this thing called mServiceLooper, and then it goes ahead and creates a new service handler with the mServiceLooper as the looper that's the parameter passed to it. That was the thing that was up here. And so what that means is when the looper is running, when somebody calls send message, and we'll see how that gets done in a second, it's going to end up calling back handle message in a separate thread of control, the thread that corresponds to the handler thread, and that will then turn around and call the onHandleIntent hook method, which will then be dispatched to your user code that you subclassed from intent service. So here is onStart. When the onStart method gets called, and this is a sort of a low-level method that gets called by the Android infrastructure, it goes ahead and uses the service handler to get a message. Now keep in mind, this message is going to go to a handler that's being handled by a background thread, and then it says, hey service handler, please handle this message. I'm going to send you a message for you to handle. So when onStart gets called, it ends up calling send message, and as you can see, what happens here is that will end up calling back to the handle message hook method that's defined on the service handler, which is running in a background thread, which will then end up dispatching the onHandleIntent hook method of your class that's subclassed from intent service. So lots of moving parts here. The main reason I talk about this is it's used very frequently throughout other parts of Android in the implementation. It's kind of cool. And we'll see, probably not in a second because I don't think we're going to have time, but we will see next class this actually implements the command processor pattern. So that's the pattern under the hood that is implementing this. If you take a look down here at the onStart command method, you'll see by default onStart command just calls onStart, which goes ahead and does that message passing. And so it'll also, based on a few things that were set when you started up, it'll set what kind of stickiness you want to have in this case, which you don't want it to be sticky. And you'll also notice that if you inherit from intent service and you, for whatever reason, want to override the onStart command, then you need to call super onStart command first and then do your other processing. That's a very common behavior in Android. You call super blah blah and then you do your stuff. So that way you can override the behavior but get the guy above you to do some other work. The on-bind method is null because this is a started service, not a bound service. And there's the on-handle intent. So anyway, it's really, really, really concise and simple, but it does some cool stuff on your behalf. So let's go back here and take a quick look. So as I was saying, you extend the intent service class, you fill in the on-handle intent method, and then that method will get passed back your intent in a separate thread of control. And as long as there's work in the work queue, this thread will not, the service, intent service will not shut down. It's only if the queue drops to 0 that the intent service shuts itself off. So if there's a big burst of requests that show up from different applications, from different activities, you will keep the intent service running until there are no more intents. And then it'll go ahead and shut itself down. So it's pretty cleverly implemented. So here's a very simple example. This is kind of like your solution in some sense, a little variant of that. And don't implement your solution like this. Let me repeat that. Do not implement your solution like this, because it's not the same as your solution, but it has elements of your solution in it. So we make a threaded download service, which extends intent service, and its on handle intent method, which should say intent, goes ahead and takes a look at various things, and based on what it finds, it'll go ahead and do some work. So we inherit from the service, the intent service class, and the on-handle intent method is basically this lifecycle hook method that is called back by the intent service, as we just saw in the code. And if you want this thing to run in a separate process, you just have to go ahead and add this little metadata to your manifest file, and that'll say run this thing in its own process. Note the inversion of control. We talk a lot about frameworks. This is another great example of a framework. You're not writing the control loop. You're not dealing with the low level of message passing. You're not dealing with concurrency. You're not really dealing with synchronization. All you know is that somebody sent you an intent, and that intent is being run in its own thread of control. And so you're being shielded from a lot of low-level details, and Android is calling you back at the appropriate time. Let's see. We have a couple of minutes. I don't want to... Yeah, we'll go ahead and stop here. What I'll talk about when we start next class is I'll talk about how to compare service with intent service, and then I'll compare service with thread with async task, and then I'll show you a whole pile of examples, and we'll talk about a pattern.